Okay, good afternoon, class. Right. So today we will continue, right? For 6.3. Okay. So how does the electricity, okay, being distributed, okay, after it being stepped up, okay, by the step up transformer, okay, after it passed through the power plant, right? Okay. So let's see the transmission and distribution of electricity. Okay, so we know from the power plant, okay, the voltage that be supplied, okay, by the power plant, okay, will be step up, okay, will be step up the voltage, will be increase the voltage by using the step up transformer. Okay, so by using the step up transformer. Okay, why? Okay, because when there too much when the electric, okay, when the electric flows, okay, through a wire for quite some time, okay, they will produce a heat. Okay, so means when there is a heat, there is a energy loss to the surrounding, so we need to step up the voltage to overcome the energy loss, okay, due to the heating of the wire. Right. So here from the power station, okay, it will be step up here. Okay, so it will be step up the voltage from 11 kilovolt, okay, to 132 kilovolt or 275 kilovolt or 500 kilovolt. Okay, so after that, all right, it will be transferred to the national grid network. Okay, and it consists of the pylon here, and there quite a long wire here. And I told you before that if the currents, okay, flows for quite some time, okay, the wire will become hot. That means the energy will be lost as the heat energy. So to overcome the heat loss, right, we need to step up the voltage. Okay, so mean after that, after we step up the voltage, you can still get the voltage, the high voltage, okay, to be used. Okay, after the energy, after the voltage is used to overcome all the heat, okay, then after that we can still get the high voltage. So let's say if we don't use the step up transformer here, okay, so we just have like 11 kilovolt here. So after it overcome all the heat energy that lost to the surrounding, okay, so the voltage that we get will be low. Okay, so this is why we have to step up the voltage. Okay, so we can overcome, okay, the heat energy that lost to the surrounding, okay, due to the heating of the wire. Right, so after that it goes to the national grid network, okay, that consists of the pylon. Okay, now if we go to the step down transformer. Okay, so the step down transformer will reduce the voltage. Okay, we decrease the voltage so it can be used. Okay, so let's say for this one, for heavy industries, so they only need 33 kilovolt. So let's say for 132 kilovolt, they need to decrease the voltage until it becomes 33 kilovolt. Okay, so they use a step down transformer. Okay, for the light industry, they need the 11 kilovolt only. Okay, so mean they need to step down to need to reduce the voltage. Okay, so they use a step down transformer. Okay, so for our house we only need like 240 volt only, so that's why we use a step down transformer. So let's say from here 33 kilovolt, all right, then it will step down to 240 volt. Okay, then after that it will transmit to our house. Okay, and another one, okay, let's say for hospital, okay, for the office, okay, they use 450 volt only. So this one also will be step down. Okay, so the only step up transformer that we use is start from the power plant, power stations to the national grid of network. So others, we just use step down transformer. Okay, we only reduce the voltage, right? So this is how does the electricity being transmit, okay, from the power station to the heavy industry, light industry, house, hospital, and also office. Okay, so national grid or network. Okay, so electric energy generated, okay, by the power station is transmitted to user via cables. So cables mean all the wire, the long wire. So that one we call it as a cables. Okay, so the national grid network is a network of high voltage cables. Okay, and it's supported by the pylons. So you already see the one that is just I just show you just now. Okay, that's the pylons, and then connect the power stations to the consumer. So the cable, which are hundreds of kilometers long, okay, have very low resistance. Okay, so it quite long. Okay, like it depends. Okay, where you want to send the electricity. Okay, so usually it's very long, like hundreds of kilometers long, and it's have a very low resistance, right? And as electric current flows the cable, the heat is produced and energy is lost, right? So, and then in order to reduce energy loss during transmission, so this one I already explained. So a step up transformer increase the voltage, thus decreases the current that flows through the cable, right? So they increase the voltage, so the current that flows through the cables become low. Okay, so then means the energy loss to the surrounding also become low. Okay, and then the step down transformer are used to decrease the voltage to the appropriate use by different types of consumer. So this one is the example: heavy industry 33 kilovolt, light industry 11 kilovolt, office and hospital like 450 volt, and house is 240 volt. Okay, so the only time they use the step up transformer is from the power plant to the national grid network. So other than that, they only use step down transformer. So what is the advantage? So the advantage of the grid system is that electrical energy from areas where demand is low can be diverted to areas where the demand of electrical power is high. So let's say in a rural area, so rural area means they not the there's not so much people live there, right? So they can divert. Okay, they can divert the electricity. Okay, to the area that still many people live there. Okay, so they can divert. So that is the advantage of using the national grid network. Okay, and also they say one place. Okay, so they say at Kepong. Okay, so they got a electrical electrical problem there. Okay, so they just only need to shut down at the area Kepong, so no need to shut down for the whole country. So that is also the advantage of the national grid network, right? Okay, so this is the example of the national grid network. So this is the pylon. So 132 kilovolt alternating current transmission cable at the Tanjung Kling Power Station. So this is at the Melaka. Okay, and 500 alternating current transmission cable at Kampung Parit Muhayat, Johor. Okay, so this one is also this is also the national grid network. So this is the example. Okay, what is the advantages of the national grid network? So the generation can be controlled on demand. Okay, so let's say there's a lot of people living there. Okay, maybe they got a new residents there. Okay, so mean they need to increase the production of electricity, right? So they can control, they can increase. So if there are not so many, they can decrease the amount of electricity produced. Okay, so if we can be controlled on demand. Okay, and this is a less interruption of supply of energy. Okay, so means like I said just now, if one place got problem, we don't need to shut down all place. Okay, only that certain place only. Okay, that we need to shut down the electricity. Okay, then another one is a cost of generation can be reduced. Okay, so you can see the national grid network, it can distribute. Okay, it can distribute the electricity to a wide area. Okay, so means you don't need to like one they need to build. Okay, you don't need to build many power plant, right? So maybe only one. Okay, they can distribute into a lot of places. Okay, so because you know, to build a power plant, okay, it needs a lot of money. Okay, so this one can cut the cost. Okay, and energy loss is reduced. Okay, this one we already discussed, right? You increase the voltage, then they reduce the current. So that means the energy loss, okay, as a heat also will be reduced. Okay, switch zone at the main substation. So the alternating current at the end of the grid flows to the switch zone at the main substation. Okay, so all the currents, okay, that flows we goes to one main substation. So they got a control there. So there they can control how does the current being distributed. Okay. So the enables the electricity to be sent to the branch when needed. Okay, so this is the switch zone at the main substation. So it used to enable the specific power station and grids to be closed for maintenance work, okay, without disrupting the electricity supply for the consumer. Okay, so it's like a backup. So let's say they want to do some maintenance work, so they don't need to shut down. Okay, you just use the switch zone here at the main station, so they will still supply you a electricity, okay, even though at the same time they are doing the maintenance, okay, for the branch. Okay, so this is called as a switch zone at the main substation. So it's just like a backup. Okay, so this is the example of the main substation. Okay, this is at Bukit Badung, Selangor. This is at Hulu Terengganu. Okay, this is at Teluk Kumbar, Pulau Pinang. Okay, this is at Sarawak, Petanak. Okay, so the another one. Okay, so what happen if we build a house? So let's say you live under the National Grid Network of Islands. So I'm sure you already know, like, for each wire that current flows, they got the magnetic fields, okay, so around it. Okay, so let's say this is the electric current. Okay, this is the wire. Okay, and the current flows to it. Okay, so when the current flows to it, surround it, there is a magnetic fields. Okay, so which direction is the magnetic field is actually depends on the direction of the current. Okay, so this one you can use the right hand grid rule, okay, to determine whether the current is clockwise or anti-clockwise. Okay, so this one I will not discuss, okay, because you will learn later, okay, if you take physics. Okay, so this is the current. So every current that flows, okay, so surrounding it, okay, there will be a magnetic field. So imagine for this one, okay, of course they got a lot of wire here, all right, and the wire is very long, and also the current that flows, okay, through a wire is very high, right? It's very high. So means if the current is very high, the magnetic fields that surround it also is very high. Okay, so means if you build, okay, a house near to the pylons or near to the national grid of network, okay, you will feel the magnetic fields, okay, and this will affect your health, of course. Okay, it can make you it can cause a cancer, right? So this is why we didn't build, okay, a house or a resident house at the near the national grid network. Okay, so a strong magnetic field is produced by the high voltage alternating current and can be detected in the surrounding area close to the pylons. Okay, so this can cause a cancer by making a pollen data sticks to the human lung, right? So and then resident living 500 meter below the wind blow power line have 29% chance of developing a lung cancer, right? And another one is the student study shows the exposure of the electromagnetic fields greater than 0.4 microtesla and the risk of cancer in children. Okay, so mostly the electromagnetic field can cause a cancer, right? Because of the electromagnetic fields. Okay, if greater than 0.4, okay, for children, it can increase the risk of cancer. And also there are two types of cancer that are commonly exposed to children as leukemia and also the brain tumor. Okay, so leukemia is actually a blood cancer, right, and also the brain tumor. So this is why we didn't build, okay, any house, okay, near to the national grid network. Okay, and another thing also, if you build under the national grid network of network pylon, you build under it, Okay, so you already know inside of your house also has an current flows also, right? Inside our house also current are flowing. So means there will be a magnetic field also produced, right? So the magnetic field produced, okay, by the pylon and also by our house, okay. So it will produce a force, okay. So this is why we didn't build, okay, house near to the network grid, okay, because of the electromagnetic fields. All right, the next is the electrical wiring system at home. Okay, so the first one is the main fuse box. So this one you can see at your living room there. So there are white box. Okay, the big white box there. Okay, so that one is a main fuse box. Okay, you can go and see. So that is a main fuse box. Okay, and then you got the electric meter. So this is where you read. Okay, what is the bill for? What is your bill? Okay, for today, sorry, for this month, right? And then you have the main switch, okay. So you have the main switch, okay. So the main switch is HD, and then after that we have a circuit breaker, and we have the distribution fuses for other circuit, right? So this is the main switch, okay. This is the main switch, and this is the meter. Okay, this is the meter, and this is the main fuse box, right? And the wire, this is a live wire, okay, live wire and neutral wire. So the live wire will supply the electricity from the power station, okay, and then this one from the house back to the power station, okay, the neutral wire, okay. And then this is a fuse, okay. The circuit breaker is actually to break, okay, how much current you will use, okay. And this is the fuse. So the fuse is actually to make sure that there is no um, the electricity, there is no leakage of electricity, okay. Let's say the flows of the current should be 10 ampere, right? So let's say the fuse is only 8, okay, 8 ampere. So the inside of the fuse is actually a thin wire. So the thin wire will melt, and uh, it will shut down the electricity. Okay, it will break the connection of the electricity, okay. So this is the uh, how does your in your house the electrical wiring system at home, okay. So let's see a video before we see each other what is the function for each part.
हमारे बाहर मीटर से जो हमारे घर में
Okay, so I just shut down the sound. Okay, so this is actually the meter, okay, the electric meter, and then it will connect it to the MCB here, and then it will connect to the electrical circuit breaker. Okay, then it is one they will uh, divide, okay, the current, okay, to the appliance, okay. So this is how does the wiring, okay, in the house, okay. So this is actually the electric meter, this is MCB, this is ELCB. Okay, can you give me a moment for a while? Wait. Okay, sorry class. I have a call from school just now. Sorry. Okay, so we stop here for a while. Okay, so let's move on to the slide just now. Okay, so this is actually the electrical wiring system at home. Okay, so just remember the main fuse box. Okay, and then the meter here, the main switch. Okay, and the circuit breaker is actually used to divide, right, the currents that need, okay, for each electrical appliance, right. Okay, so the electrical wiring system in Malaysia, so there are two types of electrical wiring system. So the first one is a one phase wiring. Okay, so this one is only for usage that below than 10 kilowatt, okay, or 50 ampere. So this one usually used at the residential area. Okay, so like our home. Okay, so for three phase wiring, so this is one phase. Okay, so for three phase wiring, okay, they are more stable for electricity usage. They're exceeding 10 kilowatt or 50 ampere. So this one usually the heavy user. So like the, oh, sorry. Wait for a moment. Oh. Okay. So we discussed until here just now, right? Okay. So this one is actually the main fuse box, right? This is the meter, this is the main switch, okay, and this is circuit breaker. So this one it used to divide the electric, the current. So they say, for lightning bulb, so how much does the currents need? So it will break down the current here. Okay, depend on how much the electrical appliance need. Okay. And this one that I just explained just now, right? So this is one phase wiring, so only suitable for usage that not more than 10 kilowatt. Okay, so this one usually used in the residential area. Okay, for three phase, this one is actually for the heavy user, okay, such as commercial and industrial area. So factories they use a three phase wiring. Okay, so this is the three phase wiring. Okay, so electricity supplies and wiring system in home. Okay, so this is the blue wire is a neutral wire. Okay, and the red wire is the live wire. Okay, so the live wire is at 240 volt. Okay, so this one that I said, the power that being supplied from the power plants, okay, to the home. Okay, so this is the where the currents enter. Okay, and then after that we have the main fuse box with one main fuse. So if anything you can just shut down this one, so all the in your house the electric current will be cut off. Okay, and this is the electric meter, so this is to measure the total units of electricity used. Okay, so now they're using the digital one, so it's much easier. Okay, and then this is the main switch. Okay, this one is to control the total current flowing through the circuit in the houses. Okay, so it control how much the current can flow to the house. Okay, then this is the earth leakage circuit breaker. So they break the circuit when too much current flows through it. Okay, so this is the earth leakage circuit breaker. Okay, this is more for the safety, right? And after this, okay, so this is you can see there are four, right? Four ways. So this is the miniature circuit breaker. So this one is to separate the final circuit to different electrical appliance. Okay, so they will divide, right? They will divide, okay, the electric current according how much the electrical appliance need. Okay, so they say for the aircon, 30 ampere, so we divide, we go 30 ampere here. We give 30 ampere to the aircon, right? So this is the part, okay, of the wiring system in our home. Okay, so this one you know already, this is the parallel, okay, they put it in the parallel circuit. So if one bulb is cannot light up, other bulbs still can light up. Okay, so that's why we use a parallel circuit in our home. Okay, so the lining circuit is made up from the live wire and neutral wire. So means for the live wire, for the current to enter, then after that when current to flow back to the power station. Okay, so that is the neutral wire. And this is the earth wire. So this one is as a safety. So they say there is a leakage of the current flows. Okay, so there will be there will be flows to the earth. Okay, so this is the earth wire. Alright, this is the power circuit that made up from the live wire, neutral wire, and also the earth wire. Okay, so this one, the one that have a 3-pin plug, right? So 3-pin socket. So that one is made from the live wire, neutral wire, and earth wire. So earth wire is actually mostly for the safety reason. Okay. Okay, 3-pin plugs and 2-pin plugs. Okay, so every country they got their own kind of plug. Okay, so for Hong Kong, this one, India like this, okay, North America, Japan, and Europe. Okay, so Malaysia is also different. So usually Malaysia is like this, right? Okay. So 3-pin plugs and 2-pin plugs. For 3-pin plugs, okay, so the electrical appliance such as electric kettle, okay, obtain the electricity from the socket on the wall through three-pin plugs. So the 3-pin plugs is actually used for the electrical appliance, okay, that need high voltage, okay, such as a air conditioner, okay, or maybe kettle, okay, and then rice cooker. Okay, so mostly for the electrical appliance that need high voltage, that we use a 3-pin plug because they got the earth wire there. So that one is for safety, because they say if anything happen, so the current will be flows down back to the earth. Okay, so there will be no short circuit. Okay, for 2-pin plug, okay, so this one using the low voltage usually. So if you use a radio, something like that, okay, so that use a 2-pin plug. Okay, low voltage. Okay, so the electrical appliance such as electric air pump obtain the electricity from the socket on the wall through 2-pin plugs. Okay, so mean for 2-pin plugs, they don't have the earth wire. So the intentional color code for wiring required to be followed for the live wire, neutral wire, and earth wire connected to 2-pin and 3-pin plugs. Okay, so this is the connection. Right, usually the yellow and green stripe, okay, this one is the earth wire. Alright, and the blue one is the live wire, and the brown one is actually the, neutral wire is the blue one, and the live wire is the brown. Okay, so this is how they connected the wire in the 3-pin plugs. Okay, and this is the fuse. Okay, so remember inside of the fuse there will be a thin wire here. It's a very thin wire. So every time they say the fuse here, the value of the fuse here is 3 ampere. Okay, but they say the current flows is 5 ampere. So what will happen? The thin wire here will melt. So when it melt, it will cut off the electricity that flows through the plug. Okay, so means that will not switch on. Right? So this is the function of the fuse. It's more like the earth wire also. Okay, but the earth wire is make the the current, okay, flows to the back to the earth. Okay, so this one it cut off. Okay, so both of it is actually more for the safety reason. So the earth wire carries leakage current to the earth. Alright, and neutral wire is carry back the electric current from the electrical appliance to the substation. Okay, so this one is actually to carry back wire to the electric current. Okay, just like we see just now, right? And the neutral wire, and the live wire is actually carry the current from the substation. Okay, goes to the electrical appliance. Okay, so there are like 2 ways. Okay, one go and one out. Okay, so the currents go through the live wire and come out from the to the neutral wire. Okay, the earth wire is for the safety reason, and the fuse is also for the safety reason. Okay, so the fuse is the melt when the excessive current flows through it. So if we cut off the current flows, okay, so means the current will not, the plug will not switch on. Okay, so this is also for the safety reason. Okay, 3-pin plug. Okay, so that's the explanation. Okay, so the safety component in the wiring system in home. So this is the main switch, okay, and this is the fuse, okay. So the fuse, they got 3 ampere, 5 ampere, 10 ampere, and 13 ampere, okay. And this is the earth decay circuit breaker, right? And this is the miniature circuit breaker, and also this is the earth wire, right? So this is lightning conductor. Usually lightning conductor is at the high building, okay? At the taller building, yeah, they have a lightning conductor. So let's say if the lightning struck, okay, they will absorb all the all the charge, okay, and flow back to the earth, okay. So this is for safety reason, right? And for miniature circuit breaker is actually this one ELCB and MACB also for the safety reason. Okay, main switch you already know this one. If anything happen, you just shut down. Okay, so all the current on the house will be cut off. Okay, and fuse also already explained just now. Okay, they got the thin wire, but later we see more about the fuse. Okay, so this is fuse. So it's a fine and short wire that heats up easily. Okay, so when the current flows through it exceed the value of the fuse, the wire of the fuse will melt and the electricity supply will be cut off. Okay, this one I already explained. Okay, so this is the fuse. Okay, so inside of it, if you see closely, there is a thin wire here. Okay, so there is thin wire here. So if there's a exit of the current flows, so this one will be melt. Okay, so when it melt, it will cut off the electric flows. Okay, so this is the glass made from glass or porcelain casing. Okay, this is the fuse wire. Okay, and this one is filled with nitrogen and quartz particle. Okay, so there are two types of fuse. The first one is the cartridge. Okay, so the cartridge one is the light, the one that we see just now. Okay, so means it put in the glass casing. Okay, but the replaceable wire fuse, okay, for this one, they don't have a casing. So every time that it's melt, you can replace the wire. Okay, so they say every time the fuse, okay, the wire of the fuse melt because of the excessive of current flows to it. So you just can replace, okay, just open the screw here and then put back and screw it again. Okay, but this one, if the fuse already melt, okay, the wire here already melt, you have to buy a new one. Okay, you have to replace with a new one. Okay, so all fuses, including cartridge fuses and replaceable wire fuses, function as the electrical safety, okay, in a circuit and the electrical appliance, okay, to protect the wires and appliances from any excessive current flows. Okay, so this is the metal cap. Okay, this is the fuse wire. So determining the value of the fuse, okay, so the value of this fuse, okay, is the maximum value of the current that can flow through a fuse without causing its fuse wire to melt. So what does it mean by here? Okay, so every time when you buy the electrical appliance, okay, they will tell you, right, what is the volt you need and what is the power of the electrical appliance. So let's say if I have the power is they say 60 watt, okay, and the volt of course 240 volt. Okay, so which fuse that I should use? Okay, so by using the formula P is equals to VI, okay, P is 60, V is 240, so you need to find I, right? So I is 60 divided by 240. So you got 0.25 ampere. Okay, so 0.25 ampere. So that's mean if more than 0.25 ampere, okay, the fuse will be met. Okay, so the fuse will be met. The thin wire, okay, inside the fuse will be met. The current will cut off. So means for the electrical appliance, they only can flow the maximum is 0.25. Okay, so you have to choose the fuse more than 0.25. Okay, so I will choose 1 ampere. Okay, so that's the closest one. Okay, I cannot choose below than 1. Okay, because if you put below than 1, so let's say the current flow 0.25, it's already melt. Okay, so choose higher than 0.25. Choose higher than what it's need. Okay, if not, that every time that you switch on, the fuse will melt. The current will be cut off. Okay, so choose fuse that higher than current needed by the electrical appliance. Okay, so to see the value of fuse depend on the value of the maximum current that flows through a circuit or electrical appliance. Okay, so this one you need to calculate. So the example here, what is the value of fuse should be installed for a toaster that use a maximum current 3.45. So you cannot choose 3 ampere. So because 3 ampere, if you say 3.45, the current for the toaster 3.45 ampere flows, then it will melt the thin wire inside the fuse, then it will be cut off. So you have to choose higher. So that means you have to choose 5 ampere. Okay, so the value of fuse that you need is 5 ampere. Don't choose lower than 3.45. Okay, so the closest one is the 5 ampere. Okay, so that's what happened. Okay, if the currents flows, okay, then what the fuse then higher than the fuse value. Okay, so safety in the use of the electrical appliance. Okay, so use electrical appliance for stated purpose only and always be installed, maintained and commissioned by a qualified person. Okay, and also make sure the electrical appliance purchase has CRIM approval. So every time when you go buy the electrical appliance, so make sure there is CRIM chop there. So that one is actually already tested and is safety. Okay, so avoid using electrical appliance continuously. So let's say if you use your laptop, okay, don't like open it like 24 hours like that. Okay, so it will cause the overheat, right? And also make sure there is enough space between the electrical appliance and the wall so there is airflow to avoid heat. Right, and place the electrical appliance that release heat and steamy such as iron from any flammable material. And the last one, make sure there is enough space from the electrical appliance, for example, computer, television and others, to avoid overheating. So don't put your electrical components or electrical appliance too close to each other. Okay, so this will allow the heat, okay, to flow, okay, to flow out. Okay, so ways to prevent electrical accidents. So replace the damaged electrical cables. Okay, do not pull out the socket with cord, right? And check the plug before use. Okay, and avoid overload. So this one especially when using the extension. Okay, so for extension you can only like using for the low voltage. Okay, don't put your rice cooker, okay, or your kettle, okay, using the extension and then use it like 3 or 4 times electrical appliance at the same time. So this will cause a short circuit, okay, overload. Alright, and then do not touch electrical appliance with wet hands. So this one you already know. Alright, do not use damaged electrical wire. So safety action when the electrical shock occur. Okay. Say here turn off the main source electric. Okay, so you know at your living room there, the main switch, right? So you turn off the main source. Okay, and keep the victim source of electricity by using insulator. So you can use a wood. Okay, so any insulator. Okay, and lay the victim an ideal position to assist breathing, and also if the victim is not breathing, apply artificial respiration at once. So this one you just blow the air into her mouth or nose. Okay, and call an ambulance. Okay, safety measures. So this is the electric shock. Okay, so that is how you measure with electric shock. Okay. Okay, so we finished for 6.3. Okay, so I will stop now. So next tomorrow, I think tomorrow. Yeah. Tomorrow actually I already assigned for you a tutorial, right? A tutorial. So I want you to answer that one. Okay, so tomorrow we will discuss. Okay. So you can take it on the Google Classroom. I already put in the Google Classroom. So exercise 6.2, 6.3 if I'm not mistaken. Okay, so you can try to do first, and tomorrow we will discuss on the tutorial time. Okay, so is it okay? Okay, so thank you. Right, bye. Have a nice day. Welcome.